lesson about blockchain, AI, and even space exploration. But how does it really work or affect your lives? Today, Seth and I, we both are gonna make the science behind it edible for everybody. Así que, toma pulque y come nopal, que el Pulque Podcast va a comenzar. It's my pleasure to welcome to this space Seth. Seth, good afternoon. How are you?
Good afternoon. Doing well.
Doing well? Seth, how would you describe yourself?
I am a computer scientist by nature.
Computer scientist.
Yes, ever since I was a very little kid, I always loved video games. And I started getting into like video game design a little bit. When I was 10 years old. I was really excited when I bought my first Mac Mini. And so it definitely started out with video game design. But ever since then, it transitioned into, in high school, I spent a lot of time doing Java coding. And I made some games like Space Invaders and just, fun stuff like that, chess, and just remaking those games and making my own version of that. And making the AI come to life was one of the coolest things that just... Even basic
AI come to life. What do you mean by that?
So I use what's called rule-based AI in those video games, and that's based off of simple if-else logic.
Okay.
So, for example, if you have a ship right here and you have a ship right here, the XY coordinates for this ship are going to be larger than the XY coordinates for this ship. So you want to decrease the XY coordinates for that. And decrease the x and y coordinates for that in order for it to start shifting over and following that other ship. And so you have to define the velocity. And one of the really cool things that I did in that game was when you move, all of the stars in the background are going to move according to their size. Because
all of the stars.
Yes, all of the stars in the background move according to their size. So in theory, the stars that are closest to you are going to be the largest stars. So it's just based off of size. So it was a lot of fun making like a basic physics engine, and that's kind of where I got a kick in this discovery, as Richard Feynman would call it. But yeah.
So these type of little games with the spaceships and like, let's say, the background of the stars and stuff. You started doing it in high school, more or less. Yeah. Which high school? Where do you come from?
George Mason High School. I come from Falls Church, Virginia, which is in the DC metropolitan area.
Okay.
And
how was it to? I mean, you are almost graduating, right?
Yeah. Pretty soon.
Computer science.
Yeah.
Department. So how is it? How has it been? How was let's say your freshman year?
Freshman year was tough.
Yeah.
So like in high school, I spent most of my time studying computer science and Chinese. I started studying Chinese in freshman year as well. And
so before freshman, you didn't speak?
I spoke a very little bit because
Did you study Chinese in the U.S.?
Yeah, I studied it in the U.S. I started when I was about 12 years old, 13 years old.
Oh, then
but like. When I was 10 years old, I started doing wushu kung fu, right?
Yeah.
And I heard Chinese being spoken on a daily basis. And so that's where I started getting interested in studying it. And so when I was in high school, I was like, okay, I definitely got to study it. And I went to the Chinese classroom every day, made some good friends, and it was the main subject that I studied in high school. And I got the best skill of Chinese in my entire high school for a non-native speaker.
Yeah.
So.
And then you came to Taiwan, and more or less, how was your Chinese level? I mean, you could communicate.
Yeah, so I was like, oh man, my Chinese is good. Like when I'm in 2016, my Chinese teacher who's from Taipei, she recommended that I apply to NTU. And I was like, man, my Chinese is good. Why don't I continue? And then I come to Taipei and I start studying in the Chinese language centers. And at that point, you kind of get humbled because it's like, oh man, I've been studying so hard for such a long time. And then like, you can't like sometimes even basic stuff you don't get. And it's like, man, this is tough. Chinese is the toughest language in the world. It takes, according to some estimates, 3,000 hours. According to some estimates, 2,000 hours, sometimes 5,000 hours. It's about 5 times longer than learning, for example, French or Spanish.
I think it's also because of the culture.
Yeah.
Because as every language, the main thing is the practice.
Yeah.
And I don't want to be, but I don't want to say nothing wrong, but I think it is a little bit harder to communicate when you are beginning with Taiwanese people.
Yes,
or
definitely.
in Chinese.
Yeah.
Because many people speak in English.
Yeah.
And they look at you struggling, so they're speak English.
I mean, like, part of it is definitely, like, you just have to practice in order to get comfortable with it, in order so that you're nervous. It's not actually based off of your skill level a lot of times.
Yeah.
So you just got to get used to putting into play what you practice, I guess, as a metaphor.
And how about when you were practicing it for your bachelor's degree? You just mentioned that you took 1 year in the language center.
Yeah, so I studied in NCKU, in their Chinese language center, CLC, for 2 semesters.
Where is NCKU?
NCKU's in Tainan.
Tainan.
Yeah, so it's like they got a CLC there, and I studied for 2 semesters there. Went back to America for doing a little work. Went back to NTU over the summer break, and I took another semester of studying Chinese then.
Yeah.
And as you were mentioning about during a bachelor's degree, I studied. It was the main non-computer science thing I studied. So I took so far 18 classes in Chinese, but I still got a ways to go. I feel like it's probably going to take maybe 2/3 of the way fully fluent. So I definitely think it takes several thousand hours to truly get
So
there.
you want to become completely fluent?
Yes.
Are you planning to get any certification?
I might take the TOCFL level 6 or band C.
Okay.
That's as far as I'm aware, that's the hardest Chinese test that exists. But it's like So. Okay,
and may I know how was your freshman year?
My freshman year was it was tough. I didn't. It's like you've been learning a really long time, and then
right now you have a Shueti, right? Max.
Max. He's a freshman. Yeah, he's also in my lab. So I'm from National Taiwan University Consensus Labs. Consensus Labs is on the 5th floor in the CSI building right beside us, and we study blockchain, AI, and I got Max to join our lab just a few months ago. So I do research for pretty much all my free time. So
I want to go a little bit
nerdy
more
stuff.
It's okay. More like looking at each year.
Yeah.
And then we can talk about your research. So I would like to know about you just mentioned your freshman year where it was hard.
Yeah.
Why it was hard?
First was the language barrier. So, like learning like calculus or learning physics and the computer science courses, they tend to have, a lot of the same vocabulary. But when it comes to math and physics especially, that was very difficult to get accustomed to.
How about calculus? How did you do with it?
Calculus, I dropped it in my first year. It's I would consider calculus to be the toughest course I've taken in my life.
Yeah, me too.
Oh yeah. I remember this.
Yeah, so, I don't know if you have any other classes that are worth 4 credits.
Yeah.
Do you have?
None.
Yeah, me neither.
None.
Calculus was the only one.
Yeah, so right now they separated calculus into two credit classes per semester. So it's 8 credits in total.
Still.
Yeah.
It's hard. And then how about your sophomore?
Sophomore year I started improving a lot.
Yeah.
Yeah, you start getting used to it. You start, breaking the ice with your classmates. You start realizing how important it is to reach out with your professors and with your classmates. And I think that's actually a fairly common story for international students at NTU, is to just make sure that you're reaching out for help. And make sure that you're also practicing your Chinese a lot.
How about your classmates? I mean, I know that there are many international students in CSI.
So there are someone from Korea, there's some Americans, some people from Latin America, people from all over the world, Indonesia, Malaysia. Yeah, so we have a diverse class.
And do you guys have like a study team?
Kind of, yeah. I tend to make study teams in like all of my classes just for. I mean, it works for me. I mean, I guess everyone just finds their own method for studying. Some people study individually better. some people study in the group better, but yeah. Basically, I have a different study group for just about every class.
Yeah.
But, yeah.
And how about your junior year? How was it? Like, how many courses were you taking?
Junior year, first semester, I wasn't taking that many required courses. I finished my required courses in last semester.
Yeah.
For computer science for the major. Yeah. For senior year. Yeah. And but junior year was okay. So sophomore year was when I started to see some improvement. Junior year was okay, and senior year, is some improvement from sophomore and junior.
May I ask, when did you join Microsoft Learn?
Yeah, so I joined that in
because I was like before the podcast, I told you like, oh, you bring the shirt, that's awesome. I think it's very cool.
They sent me like a beta student ambassador.
What is it? And how does it work?
The Microsoft Learn Student Ambassador Program is like an international program. It's headquartered in Silicon Valley, but it's everywhere in the world. They have several thousand ambassadors, and basically it's just like you're on your university campus, and you get to host events for Microsoft, basically.
Yeah.
So it's a lot of fun. They'll support you in your events, and I use that kind of in combination with AI Club.
How many events have you done? Or
so far with Microsoft Learn, about 5 or 6. Yeah. So we just hosted an AI Club business fair a couple weeks ago, and actually a couple days ago we just hosted an event with Rakuten. So I just met a guy named Mark Chen. He's the only other current student ambassador in Taiwan.
Okay, so you guys are only 2.
Yeah.
That's awesome.
But we
is it hard to turn into an ambassador?
I think you just have to make sure that you show a lot of interest. For anyone that wants to apply, I would highly recommend that you record a video when you're doing the online submission for your application.
Yeah.
It's a lot better than just placing text there for answering the questions. That's what both me and Mark did.
Okay.
So.
And then you just mentioned that you are part of AI Club.
Yeah.
What is it?
So in sophomore year, part of what kind of motivated me to reach out to my classmates was I was like, I want to meet more of my classmates, and I created AI Club in sophomore year in second semester mainly. So it's been about 2 years, and right now we've got about 40 members. Last semester.
Great. And what do you guys do?
So we do a lot of research. Right now we have an ML class on Thursdays with Professor Hu Zhongxing, and we also host like events with a lot of businesses. One of them being Asia to Japan. And so actually, for anyone watching this podcast, you're invited to
listening.
Yeah, listening to the podcast. Yeah, right. So if you're on YouTube or if you're listening to it, we have the Symposium for Quantum AI, which is SQAI, in 2021. We just created this conference, a group.
When is it going to be?
May 29th is going to be the main event. So we still got a couple weeks. But it's going to be in CSI room 103. So it's we got speakers like Sony AI. We've got the chairman of our department. We have NTU IBMQ. We have speakers from all over.
Maybe this episode is gonna be after that. So.
Okay.
But we can help you promote it.
Make sure to check out sky.org.
Yeah, for sure.
SQAI.org.
Okay.
But yeah.
Seth, you just talk about your sophomore, junior, and right now you're senior.
Yeah.
And you are doing research?
Yeah, I'm doing research in most of my spare time.
About?
Mostly AI, but also some blockchain.
What is blockchain? For all those people, because right now we're listening blockchain and cryptocurrencies and Dogecoin, we are investing, but sometimes, being honest, people don't even know what they are investing.
Yeah, so this is probably where the podcast actually gets interesting, because all the other stuff is like boring stuff about me, but blockchain.
I find it interesting.
Anyways, so like blockchain is a technology that is based on the properties of decentralization, scalability, and security. So if you look at the structure of it, you know, the so-called impossible triangle.
Impossible triangle.
Yeah. So
what is it?
It's like scalability is like referring to how vast you can create. Okay, so like blockchain is based off of what's called a peer-to-peer network. So everyone is an equal node in that network.
There's say an equal block.
Yeah,
right?
an equal node, because a block is created by the collection of nodes.
Oh, okay.
So you can think of blockchain like all of the computing power together on that peer-to-peer network is going to collectively produce the blocks. Now, these blocks are going to be what verifies and legitimizes transactions.
Yeah.
And so every blockchain has been based off of the innovative paper that was created by this entity or this person or this group called Satoshi Nakamoto, Zhongbenchong in Chinese. and basically... Zhongbenchong. It's like 聪明的 聪.
Oh.
And so some people think it's actually the identity of Satoshi Nakamoto is very much a mystery. And this is something that is like very much ingrained within the lore of blockchain itself. So he released a groundbreaking paper in 2008 called, just for Bitcoin itself. And he laid down the groundwork for what's called a distributed ledger. A distributed ledger is a revolutionary financial structure. It's not just for finance, though.
Yeah.
Blockchain can be used for an assortment of anything that you can imagine, as long as you want to prove that at a specific time or a specific place or whatever, that this information exists or existed. So you can verify anything with the blockchain. You can verify transactions, you can verify videos, you can verify images. And as I was mentioning, it's a decentralized distributed ledger. What it means by decentralized is as I was saying, every single node in the peer-to-peer network is equal. We have no centralized authority, because in traditional finance, we have a centralized authority, either the government or some sort of trust entity, and there has to be a trust factor in this.
Yeah, like, okay, before you keep on going, you just said blockchain, it's a type of a lot of nodes. Let's start from the very basic nodes that are information.
Yeah, so
a lot of nodes.
Nodes are computers, just
a computer.
Yeah,
okay.
People that provide processing power.
So there are many computers.
Yeah.
A set of computers make a block.
Yeah. So
and there are many blocks connected. That's why it's a blockchain.
Yes,
right?
Precisely. And every single block has a hash value that points to the previous block using a Merkle root.
Okay, so they are connected. It's like a root of a tree?
Yeah, the Merkle root. So the Merkle root is the technology used for hashing the transactions in each block.
Yeah. So that if you want to change one block that is above another one, you need to change both informations.
Yeah.
So it gets like harder.
It gets harder every single block. So if you want to change something from like 30 or 50 minutes ago on the Bitcoin network, you're going to have 51% of the processing power. So that
51%. So
it's
half of it.
Yeah, that's why blockchain is so difficult to hack. Now, Bitcoin uses an algorithm called proof of work. And that's specifically what where this peer-to-peer network comes into play.
Yeah.
Proof of work has a very high power consumption. Actually, if you compare the power consumption of Bitcoin, it's actually comparable to entire countries.
Yeah.
So smaller countries, maybe like Estonia or Hong Kong or whatnot. But still, it has a huge carbon footprint. Yeah. And so proof of work is very good, but it's also very power consuming. And so people are now thinking of new innovative ways. Proof of stake is okay. There's also like proof of memory, which just came out very recently.
Yeah.
And proof of memory is like, from my understanding, from what I've heard from Professor Liao, my advisor, he said that like you can have RAM or memory from your graphics card and things like that, in order to have power in that blockchain. So if you have like 100 gigabytes of RAM, then you're going to be able to do a lot of production and activity on the blockchain for that proof of memory blockchain.
Yeah.
Yeah.
So how blockchain is connected to cryptocurrency?
So blockchain is the force that's powering cryptocurrency.
What do you mean the force?
It is what creates decentralized finance. So we
decentralized because there are many computers, many blocks.
Precisely.
So it's not centralized, right?
So we have, like, in traditional finance, you have to have that trust entity in order to say this dollar has power, and we call this FIFA. Yeah, FIFA. It sounds like FIFA Cup or whatever, but but FIFA is like traditional currencies. It could be like the US dollar, or it could be renminbi, or it could be you name it. And decentralized finance and cryptocurrencies. Well, the actual term cryptocurrencies comes from cryptography. So it uses so the distributed ledger uses cryptographic principles in order to usher in a sort of decentralized network, in order for all people to have equal say or equal power as to what transactions are legitimate and which transactions are not, or which photos that were uploaded to the blockchain are legitimate and which are not.
Okay,
like that.
But let's say this. Everybody can make its own cryptocurrency, right?
Yeah, anyone can, yeah.
What would make, let's say, I don't know, someone in the world, they make Pulche dollars.
Pulche dollars.
Yeah, Pulche dollars.
Sure.
And they give themselves 1 million Pulche dollars.
Oh, yeah.
And they give the market another 1 million Pulche dollars.
Sure. Then you control half of your own currency.
Yeah, okay, but
that sometimes does happen. People create their own blockchains and they control a huge amount of the currency in that, and that's actually a way that you just literally you print your own money. It's
But is it fair?
Because that's one of the biggest arguments in blockchain right now. Is that really fair? And
because let's say you have half of it. You have 1 million. I have 1 million of these Pulche dollars. If I print another 2 million, or let's say not print, it would be create. I create another 2 million and I give it to myself as well.
Yeah.
Then you would have 1/4 of these Pulche dollars.
Yeah.
Would that?
It's not fair. Exactly.
Yeah.
I mean, a lot of cryptocurrency is based off of scam and fraud. So there's no denying that. That's just, and a huge amount of research is being invested into how do we, verify that, the legitimacy. Yeah. So like, or if people that are working on the black market, like in terms of, some people are buying illegal items, and a lot of illegal transactions are being done on cryptocurrency, untaxed things. And so, how do we make it so that we can still have oversight over a decentralized structure? So how do we have centralization over decentralized structure?
Yeah.
So that can be a little bit difficult. Every single country has different laws for mandating whether blockchain is allowed or not. For example, Singapore doesn't allow for cryptocurrency, but it does allow for blockchain itself. The United States has allowed blockchain ever since its inception.
Since what?
Ever since its creation. Since
I saw the movie Inception.
Oh yeah.
I like what?
Inception was a 2008 movie. Is that right?
I don't know. Honestly.
Yeah. I listened to the soundtrack Hans Zimmer.
Yeah.
Hans Zimmer is the greatest composer ever.
What do you think about that movie?
It's very interesting, very philosophical. Yeah.
And because I know you are very interested into the space.
Yes, very much so.
Space exploration. What can you share with us about it?
So, I'm pretty sure everyone has heard of like this, all the, innovation that's going on with space exploration in terms of NASA having their rover Perseverance, which was named by an elementary school kid. And so that's pretty cool. And
what's the name of this kid?
Perseverance. I'm not sure what the student's name is, but Then we have like SpaceX by Elon Musk, and they're offering, flights of like, if you pay $500,000, then you can go travel to Mars.
Would you travel to Mars?
Yes.
Okay.
Very, very resounding yes. And there's actually a very large problem, and that was pointed out by Neil deGrasse Tyson, is that the problem with, restaurants on the moon is that they have no atmosphere.
Yeah. Okay. I can't believe I just had a heart attack. I just had a love attack I couldn't come back from.
That was the funniest joke ever, man.
But, okay, Seth, tell me a little bit about AI, let's say.
Yeah, so current AI is actually the origins of the term artificial intelligence were created by Marvin Minsky in the 1950s. And there was all this excitement in this early stage of AI about what the capabilities of AI will bring. And there was also the beginning of the development of neural networks.
But neural networks, there are many people scared about AI.
Yeah.
And there is this, Gabriel just mentioned, there's this thing about Facebook doing a type of machine that could communicate with other one. What can you tell us about it?
We can have so the field of AI communicating with humans and with humans communicating with the computer, or AI in general, is referred to as natural language processing. And natural language processing has all kinds of subsets, like natural language understanding, and basically we have it to the stage where huge language models like GPT-2 and GPT-3, which are developed by OpenAI by Elon Musk. He's one of the founders. Oh, by the way, OpenAI's co-founder and president, he just left OpenAI for news. But essentially, GPT-3 is basically the biggest language model. I mean, you could also GPT-3. Yeah. It's a closed source language model. You have to, if you want to get a license for it, in order to use it, you have to apply. I believe that they're only the largest of companies are actually eligible for it. I'm not even sure if academic institutions are eligible.
Okay.
I myself have applied 10 times to it.
All neglected.
Yeah. And some people in my lab have also applied for it because we want to do research on it. But the reason that they're keeping it so closed and so restricted is because we have it. There's a big AI safety question to giving these models out. So it could be used for all kinds of malicious intent. It could be used for scamming. Actually, last year, MIT Technology Review.
Army.
It could be used for the army. It could be used for espionage. It could be used for all kinds of things.
Seth, did you saw the news about this type of dog?
Dogecoin? I have...
No, not Dogecoin.
Oh.
There was a type of dog that was a robot that the French army bought it.
Oh, really?
And they were using it as a weapon.
Wow.
Because this dog could, pick up a bomb, let's say, a ball.
Yeah,
and the French army, they use it for army purposes.
This is one of the biggest topics of AI safety. Not only the danger of large language models, but also in terms of AI weaponry and things like that. So if we have, there's something called computer vision. If you guys, what you guys could take out of this is NLP and CV computer vision. You can use computer vision in combination, so object detection, and the same principles that are kind of powering autonomous driving are also powering autonomous weaponry.
Yeah.
Drones that are able to navigate themselves.
Right now, I was going to tell you just mentioned automated vehicles.
Oh, yeah.
Right now, we've all listened about some accidents.
AV.
Imagine if you find an accident with an automatized weapon.
Oh, yeah.
It turns out...
they misidentify a person. This happens in law enforcement all the time.
Yeah.
Where there is, and this is one of
Right now, even sometimes your dog doesn't recognizes you and attacks you, right?
Yeah, yeah.
Imagine about a weapon that it's metal.
Yeah.
And
it's like a drone that's like flying into this room,
yeah,
and
with
it's like
blades
and you're just like
yeah.
I mean, like, thankfully that didn't spill.
Bro.
I mean, like, I would probably be putting my hands up right now. Anyways, so I mean, it's a very big AI safety question. You can understand just the impacts of, you know, all these different things, everything from autonomous vehicles, AV, to autonomous weaponry, to you know, scamming with NLP, all these different things. So
yeah.
But I get most of my information, as I was mentioning, about MIT Technology Review. Highly recommend it.
Yeah. So where do you think AI is going?
In what time frame?
Time frame, let's say 5 years.
Yeah. So I think that this is very interesting, because I think that right now America has the number one, the top AI capability. Within the next 5 years, it's arguable that China is going to have China. Yeah, it's going to have the top AI capability. So we could separate that into like corporate AI. We could separate in perception AI. They're all different categories of AI. Li Kai-fu describes 4 of them.
Yeah.
Li Kai-fu is one of the main figures in AI in all of China. Yeah. And he's probably the number one most famous. And he describes these 4 sections of AI. Right now, America is leading and or tied with China in 3 of those 4. And in one of the 4, China is leading. Within the next 5 years, China is going to be leading in 3 of them. And so
leading in 3 of them.
Yeah, right now.
How many?
Out of 4. So
that's so nice.
so China has the most big data. There's no question about that.
Yeah.
America follows behind quickly. So the second most amount of big data. AI, what it needs.
Where is Mexico?
I'm not sure how Mexico ranks, or how in terms of, but
what sorry you were saying?
So it's like AI right now needs big data in order to power it. It's not about the AI algorithm used. It's not about how it's not so much about the AI algorithm used. For example, k-means clustering, or unsupervised learning, supervised learning, reinforcement learning, all kinds of different paradigms. As long as you're using a usable and applicable enough algorithm, it definitely comes down to how much data and how good of quality of data that you have.
Yeah.
And that is going to be what powers the next generation of AI. It's going to be ultra large scale generation of big data, from everything from edge devices to this computer right here to your phone. Right now, everyone's probably heard the term IoT, Internet of Things. On the Internet of Things, there are billions of connected devices serving as collection points, mapping out our daily movements and our locations. And we are creating higher and higher quality of data. And if you upload your picture onto Facebook, that's going to be automatically recognized by CV technology as being you, because it uses landmarks on your face and all different kinds of interesting technology. But yeah, one of the biggest questions as a result of that is, how do you protect your digital footprint? So that, I mean, like, what do you not buy a phone? Do you not download those apps, that all of the most useful apps like Facebook and Twitter? I mean, if you're serious about protecting your identity, not only it's a very difficult thing to do right now.
Yeah,
it is a very difficult thing to so to speak, cover up your digital footprint. It's almost impossible. But
nowadays it's almost impossible.
Yeah.
Because you use your finger to unlock your phone, sometimes your face.
And it's definitely in every company's.
You put your birthday, you put your name.
Yeah.
Everything.
Oh, and it's more than that. And they'll use web crawlers to collect data from all over the place about you. Not just specific data about that you supply to the app, but also data that exists about you online.
Right now, every person is just a group of numbers in a set of data.
Yeah.
Right.
Yeah. When it comes down to it, essentially. So in computer vision, yeah, as you're saying about a group of numbers, you can have, everything's made of vectors. So in AI, the data structure is vectors, two-dimensional vectors. So in matrices, and if you understand this on a low level, computer vision can use different algorithms for making sense of what would seem as just like a blur, because it zooms in so close, and collects information from very, very close by a local region of pixels that would just make no sense to humans. And it's able to use different algorithms to collect patterns on, for example, if you're thinking about identifying whether it's a dog or a cat, you don't have to tell the AI, okay, the cat has more up of ears, or has like green eyes more often, or cats are smaller more often. You don't have to tell an AI anything.
He'll do it
because it'll just do it itself. But the I should say the trick to it, the key to it, is that you have to have enough data. So if you're running on 100 pictures, and you're expecting to get the next top CV model, forget about it. You need to have 100,000, or for example, ImageNet, the largest data set, largest CV data set in the world, that was created in about 12 years ago by Google. Right now it has about 15 million images. And
50 million images.
15 million images. And what's interesting about this is that the computer is so good at collecting different data. It's so good at collecting different information on this data that it can spot patterns, not only that we wouldn't imagine, but in application scenarios that we would never imagine. So, for example, I was working on a research project called 3-to-1 pipeline, and 3-to-1 pipeline is like biomedical imagery. We use the Kaggle pneumonia data set, and the problem with medical data sets is that they have a very small. Their data set is very small. And typically, because the number of patients, of course, is going to be limited. And this is ever more the case with more and more rare diseases. And this is why it gets exponentially more difficult to treat uncommon diseases, is because there's no data on it, first of all. Second of all, the number of clinicians, the number of doctors that know how to treat it, could be very sparse. It could be very, very few and far between, or the number of hospitals. And so what we do with 3-to-1 pipeline is we augment this, 15,000, 20,000 size, 25,000 to be precise, I remember now, data set. And we augment it with what's called a generative adversarial network. A generative adversarial network is able to effectively produce new images. For example, if you train it on a data set for pneumonia, then it could produce new, real-looking, very realistic-looking pneumonia pictures.
Yeah.
And essentially, that could be useful for increasing the accuracy of the model. So basically, you can use a model to
compare,
to train, to train on an existing data set, and then use the knowledge that you get from that data set to produce more images. And so that's augmentation with GANs.
Looking at the variation and
absolutely. And yeah, that's another thing, is like statistics is like one of the most, linear algebra, probability, and also a little bit of calculus. It depends on the program. That's where the math comes in for data science.
Yeah, many people, when they said, even calculus.
Yeah, I would say number one in importance, arguably, for the data itself, is linear algebra, and for the algorithms, it'd be probability. So, for example, what is the probability that this is a dog or a cat? That would be on a simple level, but yeah.
Okay, Seth, may I ask what's next for you? What are your plans?
I want to continue studying Chinese and AI, and I absolutely love studying blockchain. I'm trying to publish 10 papers before I graduate.
Yeah, I've seen that you already have some, right?
I only have 2 right now, but so the 3-to-1 pipeline is one. Then we also just released. Actually, I just attended the conference for that. It's called ICBC, the International Conference on Blockchain and Cryptocurrency. 2021, and we published our multi-layer blockchain paper to that. And so I was a co-first author for that, and then the second author for my for the medical imaging one.
Whoa, that's great.
I'm working on a bunch of different ones, so hopefully see how they turn out. But one of them is quantum AI, and then there's also also a few more for blockchain. But yeah.
Hopefully, everything's gonna be fine.
Yeah.
Yeah. Well, Seth, thank you very much for coming.
Thank you for having me.
And no, it was a pleasure. Thank you very much for sharing all your
I'm
knowledge.
glad you have joined.
Huh?
Glad to have joined, and I'm looking forward to seeing the Pulche
Pulche
cryptocurrency.
How do you say chemistry?
Chemistry.
CHE, right?
Yeah, chemistry.
I have this talk with many people.
I'm looking forward to seeing the Pulche cryptocurrency come to the market.
Pulche dollars, huh? Yeah, for sure. Well, thank you very much, and see you next time. Thank you very much for watching this episode. Like the video in case you liked it, and leave a comment below for further improvement of our content. As well, if you like topics such as new technologies, research done in universities, or even wonderful stories of incredible people, subscribe to our channel. This is how you find us in social media. I want to give a special thanks to all my sponsors and team members. Y recuerda, toma pulque y come nopal, que la próxima semana otro video